At one point or another, we've all tried to count as far as we possibly could, but we all give up motivation after a while, because there's just going to be a number with an impossible amount of zeros. We're all told of something called infinity, larger than any real number. But what if I told you there were concepts even larger than that infinity?
Let me explain. Imagine you're a librarian and you have an empty bookshelf like this, and you have a huge pile of books that you need to sort in. Now, imagine every single one of these books is a number, and this shelf is kind of like a number line. Now, just to illustrate my point, I have a few books here with numbers on them. 1, 2, 3, 4, 5. Just like in a number line, I would put 1 at the start, then 2, and then 3, and then so on and so forth. But let's say I'm a pretty slow librarian, and I can only put one book in 1 minute. From basic knowledge of rates, that means that we could put 2 books in 2 minutes, 3 books in 3 minutes, 4 books in 4 minutes, and so on and so forth. Now, what that means is that technically I can put an infinite amount of books in an infinite amount of minutes. Even though I would never technically stop putting books on the shelf, there would be a direct one-to-one correlation between every single number and every single minute I take putting a book in the shelf. That's what we call a bijection. The existence of this bijection and a clear starting point means that this set, like the set of all real numbers, is countably infinite, expressed by this number right here.
Now that you know a little bit about countable infinities, let me tell you about uncountable infinities. Take the numbers between 0 and 1 as an example. You couldn't even find the first number between them, since you could never end the decimal. This is expressed by the symbol on screen now. With all of this, you should now know some basics so that you can research more on this fascinating topic on your own. Thank you for listening.